Te he Māori ora, ina mana, ina reel, ina hoe whā. Tēnā koutou, tēnā koutou, tēnā koutou katoa. Hi everyone and welcome to Spark's IoT Insider webinar. I am Christine from the Spark IoT sales team and your host for today's session. Before I welcome our speakers, Teat from Tussock Innovations and Hugh Blake-Manson from Citycare, I'll go through a bit of webinar housekeeping. Firstly, you're welcome to send in your questions during the webinar. In fact, we encourage it. Simply type in your question in the questions area on the right-hand side of your screen, and we'll be answering those at the end of the presentations. We'll be running a poll that I'll put up between the two speakers, so be sure to jump on and we'll give you the results during the webinar. Also to note, this webinar is being recorded and you will have access to the recording after the webinar has concluded. Okay, let's get on with things. We are first going to hear from Jessie and then Hugh. A little introduction to Jessie Teat, who is joining us from Dunedin. Co-founder and CEO of Tussock Innovation, Jessie is an IoT hardware designer who likes to push technology to the edge. Tussock Innovation was started in 2013 as a general IoT design consultancy, but quickly pivoted to focus on a single critical market, water. His Waterwatch branded products have earned innovation awards in agriculture and stormwater, as well as a silver at the Best Design Awards. I'd like to welcome Jessie to the webinar stage. Hey, Jessie.
Thanks for the introduction, Christine.
No problems at all. I'll hand the stage over to you.
Thank you. Firstly, I should explain the concept of pushing technology to the edge. You'll notice during the talk that I focus on continual improvement as we discover new solutions to particular problems. The push to the edge concept is actually around us driving technology out to each of the senses. We want them to become more aware of their purpose so that they can respond as needed. Now, let's get back to where it all started. I'm a father, CEO, and engineer, more or less in that order of priority at the moment. I have 13 years experience as an engineer, 5 as a CEO, and 1 as a father. You could probably say I'm working hard to improve my weaker skill set. I co-founded Tussock Innovation in 2013 with the goal of creating well-integrated products that are easy to use, follow modern design standards, and work out of the box. The aim was to make something that was slick and fun to use, like the iPhone. I guess we were very optimistic. In 2015, we joined a working group, and I volunteered our team to solve a flooding problem. Nearly $35 million worth of damage occurred in Dunedin's November 2015 flood. It was found that poor maintenance programs played a major part in the issue. 5 years later, our Waterwatch brand is our main business focus. Our brand vision is to provide smart, stress-free water management. We aim to offer a balance of improvement to operational efficiency and tools that aid customer transparency, education, and engagement. Now, this will sound a bit like a pitch, but it's a further introduction to what we do and how we use IoT technology to do it. In Christchurch, 18% of their water is lost to leaks. That's 9 billion litres a year, or 70 Olympic swimming pools a week. This is a huge operational inefficiency that can be improved on. But in this situation, the water is lost across an entire network. It's not just a single leaky main. At times, up to 50 reports are received a day of leaks. There's a real need to help improve operations while engaging the customer. Christchurch City isn't the worst. Auckland, Wellington, and Dunedin lose 23% of their water. And this is not solely a city problem. It extends to agriculture, horticulture, environmental studies, and basically any situation where liquids are stored and transported. Behind the scenes, the people maintaining the water infrastructure and continually being pushed to do more. Their lives are rife with day-to-day stress, trying to keep the taps running. This animation exemplifies how archaic the current process can be. Sending people to site periodically to check on things is what we've done for years. Operating in this manner only provides us with a snapshot in time, a single data point. We all know we can do better, and some do. Many of you have replaced this manual process with SCADA systems, automating pump stations and control gates. By now, thanks to low-cost battery IoT technology, we can further improve our efficiency and transform our businesses. Let's take a look at how we tackle this type of problem with Waterwatch. While I continue, visualize how you can implement some of these concepts in your business. And if you have questions, we can discuss them later near the end of the webinar. Our system learns how water is stored, delivered, and consumed. It combines remote IoT sensing, flow, level, pressure, and other sensors to collect data and deliver powerful analytics insights to the people who need them. If you've ever collected data at any scale before, you'll know that it can be very difficult to sift through and make sense of. The more sensors you deploy, the better your resolution for pinpointing problems are, but dashboards quickly become cluttered and overwhelmed at scale. This slide is a water metering and analytics demonstration and shows how data can be simplified. So don't focus on the bulk dashboards and data. Limit the information overload, instead focusing on actionable insights that users can understand. What are the consumption trends for a particular area, for example? Does the water balance make sense? Or are there particular sites with higher than expected usage? Remember, we're not targeting just water experts, but we're helping transform operations, teams, and customers. The insights we gather will help managers and planners improve their maintenance programs, budget for future water use, decide how and where to save water, and plan infrastructure work. As part of the engagement program, we enable customers to monitor their own usage, educating them along the way, identifying where their water is going, how they're using it, and if they have any leaks, exactly where to go to fix them. So you're thinking this all sounds quite good. But before we rush out and start deploying sensors in the field, a key takeaway note. We need to plan to manage our sensor deployment lifecycle. Remember, low-cost IoT sensors are not comparable with SCADA systems. They're generally not always on, connected, or ready for IoT staff to debug and probe what's going on. So plan for how to support the product in the field, what information is needed if something fails, and if an issue is discovered, how can you solve it on-site or remotely? You can even think about how you could crowdsource a solution. A central part of any IoT deployment is the sensor and sensor management platform. These are normally very highly and tightly integrated, so I recommend working with a manufacturer or someone who knows the product inside out in this space. Most cheap, low-power IoT devices may not have any fault detection or logging, and a number of solutions don't even have a sensor, so you may need to integrate them yourself. This research phase is very important. We also want to make sure that any logging that's done is going to the right place, and that we have access to it when it is needed. In this next section, I'd like to brush over a few different installations while touching on some of the benefits and customer outcomes. We'll also look at the tools that we used along the way. In 2018, we deployed an agriculture demo for Meat and Livestock Australia. The MLA brief was prove IoT while verifying new tools and value for our stakeholders. A pretty minimal brief, to say the least. So we set out to understand more about their test farm. It's one of 5 sheep and beef farms operated as part of a pastoral company. There are staff living on site in a state home, a large river and floodplain that you see in the center of the picture here, lots of thirsty sheep and cattle, and some really interesting water systems. So it's actually a flood management scheme a stock water and irrigation scheme altogether. The system has been in place for 2 years now. The first year of the flood management scheme was uneventful, no alarms, nothing interesting. But this past year, however, has seen several floods cutting off access to the eastern part of the farm. The majority of the animals and the pastoral land are on that side. The most recent flood was so large that it destroyed the bridges and washed out the flood sensor network. The orange icons in the middle show where the flood sensor network was once before. Luckily, no lives were lost in this flooding. We've monitored 22 assets on the stock water and irrigation schemes. The plan was primarily to identify how much water was retained in each asset. However, subsequent software releases have provided leak and blockage detection. If the Koala team were to expand the water monitoring scheme, the next step would be to provide arterial flow meters. This would enable high accuracy water balancing and the ability to pinpoint exact leak locations. Now, this style of installation is common for corporate farms where there are a number of staff coming and going daily, and efficiency gains are primarily a KPI measure. The technology allows each of the staff to have an overview of the system wherever their location, leading to reduced travel time and cost. Now, this is not always the focus for private and smaller farms. They tend to focus more on personal stress reduction and animal welfare, which is afforded by knowing where the water is and that it's available to their animals. Shortly, Hugh will explain how they utilise this technology within their rural water scheme contracts. His goal, among others, was to further enhance their service, find illegal connections, and provide better customer transparency. We've utilised Spark's 4G CAT M1 IoT network for this deployment. It allows us to deploy new machine learning models and features to the sensors as we prove them in our lab. This also means that Hugh and his team get the most out of the technology investment. Although we initially designed our radar level sensor for tank monitoring, we also visualized that it could be used in underground installation. On each of these tanks that you see in front of us, there's one of our radar level sensors. We believed that the radar system would outshine our ultrasonic system that we've been using in earlier underground deployments. Citycare could also see the benefit in using the technology, so we began to run some trials. Now, like the rural water scheme, we selected an IoT network that would allow us to upgrade features and test scenarios as the trial progressed. The desired outcome from this collaboration was to identify if our radar could be used to drive maintenance insights and improve response times within the wastewater network. The trials, along with other installations, have proven that this network can support communication of our sensors even at 3 meters below road level. A discovery that's enabled us to use the radar for I&I. I&I is the study of infiltration in waste and stormwater networks. For I&I, data is collected from sensors and cross-correlated with other known factors, like rainwater for the particular catchment, or rainfall for the particular catchment. With this data, you can identify when and where unintended contaminants are entering your network and improve efficiency while reducing pollution. I&I allows engineers and construction teams to concentrate their energy on replacing damaged or underperforming sections of the water network. This results in huge cost savings for councils. Now, I want to touch on how it's possible to support the deployment lifecycle in these scenarios. We use 2 different tools. One, our customers invite us to view their data and check on sensor performance. The second option uses metadata. This information is, it's information to select sensors that report a variety, it's important to select sensors that report a variety of health and status information, which you can log. I mentioned earlier that it's nice to have some flexibility to analyze and manipulate this data. We build additional applications to access our sensor metadata, which creates a variety of additional benefits for our customers. Think of it as a parallel portal designed for a different set of users, these users being our support staff. In the product support instance, we're able to display and manipulate sensor metadata, allowing our staff and representatives to drill down and investigate any customer problem. Like many companies, we've had to overcome hurdles along the way. This year, we issued a big battery recall because the internal impedance of our batteries wasn't following the manufacturer specification. This would have been an impossible task to detect and resolve with our IoT analytics. In another instance, we had a malfunctioning sensor due to a faulty microchip. Down to good planning, we actually store information all the way along our production process. Everything, including the circuit board ID, batch number, and the person who's produced the sensor. This information helped us to identify the batches that were affected, and we sent out replacement parts. I suggest that you specify the same level of detail for your deployments, especially if you plan to deploy at scale. You'll see on the screen here that we have the ability to release new firmware to devices or batches of devices. We can make sales and manage subscriptions. We can also support distributors, as I mentioned, who can dive into the health and debug analytics of each of the customers' sensors. We can analyze the health of a single customer installation or an entire Australasian deployment, as you see on screen. The next key takeaway I'd like to address is have a physical deployment plan. Remember, not all installations are the same. What's used in Australia and other parts of the world may not work for us. Most Australian and European water meters, for example, are located above the ground, while in New Zealand, we locate them below the ground in a water meter box. A large number of these meters end up submerged or flooded. So we need to make sure that our IoT meter networks and sensor systems are robust and locally verified. The smallest variations in installation methodology could invalidate any ROI studies that have been presented to us in the past. Talk to others who have completed installations like this before, engage how the process has gone for them, and it can be used in your instance. The goal during installation should be to verify the complete install from end to end. We want to prove that the sensor readings are correct, then send the data via the selected method to its end destination. Look, it sounds simple, but often many of these steps are missed or incomplete, so only part of the installation is verified. This install that you see on screen is part of a backflow prevention scheme. It monitors the stormwater retention capacity in Brisbane. Because Brisbane is a low-lying council, it relies on backflow prevention and a large capacity stormwater system to prevent surface flooding during high tides. If the backflow prevention gates fail, our sensors trigger alarms and the team can head out to the affected gates. Now, it's hard to imagine this guy in front of you pulling out his computer, sitting down on the side of the road while he verifies and programs the sensor that's being installed. The sensor you see is actually attached to the lid, the manhole cover lid. Some equipment can take up to 2 hours to set up once installed, but this doesn't need to be the norm, and this is not what's the case for our equipment. I encourage you to expect more from your IoT suppliers. Do away with the LEDs and LCD screens if you're only going to use them once during commissioning. Instead, we like to crowdsource our technology. Most of us have a smartphone in our pocket, which is internet connected, has a GPS, Bluetooth, and a touchscreen. This slide depicts a common theme of most of our deployments. Our sensors are on poles, bridges, tanks, or underground. We believe that it's not possible to properly verify an installation unless it's in its final installation place. A Bluetooth-based communication system, which allows users to directly communicate with the sensor while they are in the field, is a better option. This innovation means that any issues detected at the site can be fixed before the installer leaves. It crowdsources technology and forms part of our backup diagnostics system. The installer of this sensor is unlikely to have climbed the pole and plugged into the sensor to verify the level reading below, nor will they have waited around for the sensor to take a reading and send it to the IoT network. Why wait around when all of this can be completed and verified through a mobile app? I'll leave you now to contemplate how you tackle your next IoT deployment, and hope this has been informative. Thanks again to Spark for the opportunity to present, and please don't forget to ask questions.
Thanks, Jesse, and well done to presenting in this, what is quite an unusual forum, a webinar. It's always very hard to actually just talk continuously to a blank screen, so we do appreciate that. It's also been great hearing about the considerable water loss happening across the country in our water systems. Most of us have perhaps heard it in various different formats, but also interesting to hear some of your learnings and how your technology is a different way for organisations to visualise this and then make informed decisions. I know many of our audience will want to hear more from Jesse, and he'll be coming back to answer your questions after we hear from Hugh. So please do head over to our questions page and put in as many questions there. You can also upvote them. And so we'll hear from Jesse again soon. Thanks, Jesse. Great. Now, this is actually an opportunity to head over to our poll, please. You'll see the poll tab on your screen, again on the right hand side next to the questions tab, and we'll leave it up for about 10 minutes and then we'll look at the results at the end of the presentations. The poll questions are you planning or implementing an IoT trial in the next few months? And also please remember to put your questions, as I say, into the questions tab. And we'll bring both presenters back on stage at the end to answer those questions, or as many as we can. Now we're going to invite Hugh Blake-Manson to the webinar stage. As Citycare's water technology sector lead, Hugh delivers IoT solutions for councils, consultants and contractors across New Zealand. He has 20 years of Three Waters asset engineering, management and design experience. At Citycare Water, Hugh has managed significant rollouts of smart metering networks, water quality monitoring systems, and network analysis delivered as a service. Hey, how are you, Hugh?
Kia ora, I'm fine. Thank you very much, Christine.
Great. Well, look, I'm going to hand the stage over to you.
Great. Thank you very much. So again, Christine and Spark, thanks for having me on. I really, really appreciate the opportunity. So a tiny little bit more about me. My whānau have been in New Zealand and Canterbury since 1842. So from a rural farming background, but we have over that time spread around Canterbury and some of the country. So we'd like to think we have a really strong vested interest in what goes on in our communities. From a Citycare point of view, we're the largest Three Waters maintenance provider across Aotearoa, and for us, and in particular in my part of the business, we support our operations and maintenance contracts, but also look further afield and challenge ourselves to bring in technology and apply it to our contracts and for the benefit of our customers and clients. That might seem a little quaint, but it really is a sincere and a purposeful drive for us. We really absolutely need that technology to make a difference in our communities. So let's have a look at what we're up to. I'm going to have to talk a wee bit about applying some of this fantastic Tussock technology to one of our contracts, but it has parallels and use cases for us across New Zealand. We're going to have a wee look at how we've applied, as Jesse indicated earlier, the use of tank monitoring to look and get insights on the levels and the quality. Now, you might be a little surprised how level monitoring can help you get insights into quality, and I'll explain a little more about that in a minute. So also want to take a wee pause for a minute and just remind you that there are so many different technologies out there. It is so easy to head down what I'll call a rabbit hole and thinking that the technology or the solution you might have in your hands or is available is the right one. You need to look under the hood and have a good talk to your provider and deeply understand what it is you're being offered and whether you can work with them, and they'll work with you to follow through the whole life cycle of that technology. And that's certainly why we're here now with Spark and Tussock, because we've lived and worked together to deliver these solutions. So let's have a look at water tanks and the solution. We're talking about rural and urban locations. They are sparsely populated, and in particular, this looking at the map that hopefully you can all see on the left-hand side. My left-hand side, you will see a river. That is the mighty Clutha River. This area has been covered in snow for the last 48 hours. It certainly doesn't look green today. It might shortly. But we're talking about places that are hard to get to, relatively speaking, and therefore they require a solution from us with Tussock that is out of the box, robust, and gives us a deep, immediate insight into what is going on. So what we have here is a rural water network. Small diameter pipes and what's called restricted takes. So a little bit of water trickling in the tank over 24 hours to provide the sheep, beef and dairy farmers and the householders with the water they need. We stood up a deployment of Tussock sensors across these tanks and this leg of the network. Now, we're talking about networks with ultimately in the order of 20,000 kilometers of pipe work and thousands upon thousands of water tanks. This is simply just a representation of what we've already achieved using tank level sensing. So you can see here the green dots and hopefully the number inside it. It tells us what the level is. Well, that's really powerful, and I'll explain that a bit further on how powerful that is for us as an operations and maintenance contractor to deliver the service that we need and we've agreed, the KPIs and performance measures. So in short, though, it enables our people on the ground to and today, and quite seriously, be able to be in the office or at their homes and see what is going on out of these properties. This is a vital resource. These property owners, in some cases, this is their only source of clean, safe to drink water, and their stock need this resource to survive. And it's part of their core business and part of their income. So stability is really important for us, and continuity and backup and support. We need a stable communications network, which Spark provides. We need stable devices, and when they're not, and I know Jesse touched on this, when there are issues, and there are from time to time, let's face it, I believe we have issues with our mobile phones some days. When there are issues, they are resolved quickly. We're not afraid to fail fast, get things done, change and evolve really quickly. What we have here is stable and it's fit for purpose. So let's look at they've looked at levels very quickly. Let's look at quality from a quality point of view. The same technology has enabled us to, in urban and rural locations, determine if someone is accessing that water storage reservoir simply by the movement and the acceleration. So those two data points combined give us a really powerful yet simple insight into what's going on at that site. We can make decisions on a 24/7 basis without having to go to site to determine whether we send a truck out or in a person at midnight on a rainy night or on a frosty night, or we can wait and do this during daylight hours. So that also allows us to manage and support the health and safety of our teams, which is paramount, just as it is to supply clean, safe to drink water. So we'll just take a step forward and look at the information we get from the tank mounted sensors. So here's a really simple yet insightful set of data that we obtain on a 24/7 basis from that technology, again to allow us to target our operations and maintenance services. We can, using logic and machine learning now, quickly identify if we're getting steady fill rates across these tank systems. We can also look for things that are different, the anomalies I'll call them. Now, while this is a generic and not actually about the particular property, we have identified clearly when customers have decided to take some control into their own hands and remove restrictors. In other words, provide what we'd call an urban standard service in a rural setting. In other words, they've opened up a pipe into full flow. Immediately, that has a negative impact on their other customers in the network. They're not getting what they need, and it also is not really in keeping with the spirit of supplying water across that network. We are able to tell within an hour or so if there is a problem. That is a phenomenal change compared to anything up to 48 hours to a week previous, where we wouldn't necessarily know where to target our effort and what to look for. In this case, the red triangle tells us that a restrictor has been removed from the inlet to the tank. In other cases, we can see slow declines or increases outside the norm and go, there might be something in that water pipe that we need to flush out or we need to remove. Someone's been working upstream, a contractor's hit a water main, is doing some extensions. We can now tell the subtleties of that information, where to target our effort on the pipe network and what tools and resources to take. That, I just can't emphasize enough, that is a massive step change for us, and that insight we're getting from the information that Tussock have enabled us to obtain is fantastic. So we use this wonderful technology across the rural network and the urban network as one example of the Citycare's IoT deployment. It allows us to get access and insight to rural networks with our scarce resources. We only have so many people that are able to go to so many sites per day. It is what it is, and that's from a contract and commercial point of view. So we have to find a different way of doing things. We're now able to supply water on a continuous basis, or in reality, where we're unable to, we can now advise the customers to conserve that resource until we bring it back up online. using other separate databases where we have access to their text messaging service. We can inform them, hey, there's a problem. Now we've realized it before you realized it. Now, actually, can you just conserve water for a while and we'll come back to you? So really important. And this also drives economies, efficiencies. We're able to demonstrate not only improved response time in terms of KPIs, but the cost savings by targeting our time and effort. That map, if you recall it and look back, is really important. These are really relatively sparsely populated places, and they represent a fair bit of rural New Zealand, in my view. With that targeting of resources, we can get the job done in good time. So, looking forward, there's always a change and there's always the next step. That partnership with Tussock has been essential to allow us to consider and take next steps. There are some places that require a different solution. So satellite connectability in the past has been very price prohibitive. We're on the cusp of being able to use satellite systems at an affordable value in the right places to allow us to get access almost anywhere in the environments we work in. And that's also a really important step in watching and waiting and looking at how we can apply that technology. We're also looking at the next steps using that logic and machine learning to see where we can make that 1 or 2% change in the efficiency of allocating our staff, our resources, and efficiency in delivering water. 1 or 2 more data points may make a huge difference now, and they are things like flow meters and pressure. None of that technology is new. It's just harnessing those data points and applying them with the level information that that we can already see and are starting to test as improvements to delivering our service. There's also this thing called AI. Now, for me, that's in the future. Those that I guess work in the high tech space could tell me a lot more about it. But we look to the future and say, how much can technology solve our problems? And we're just keeping a watching brief with the great support of Spark and Tussock. So I'm almost at the end, but I just wanted to come back to the partnerships. Partnerships are so important. We all have, in my view, really strong niches we work in. And when we partner up and collaborate, we come up with fantastic solutions. And I think things like this, though some might see them as simple, are really world leading. They are fantastic. They seem simple, and they solve some problems that would cover a large part of the community. So keep those partnerships going. So look, I'd just like to wrap up and saying I appreciate the fantastic opportunity that Christine and Spark have enabled me to come on this webinar and talk to you and with you, and also Tussock and that partnership approach and the abilities and technology they've provided has been fantastic. Thanks, Christine.
Thanks, Hugh. It really has been great to hear how Citycare is introducing the new technology and how it's improving productivity and providing better insights when you're managing your rural water supplies. And I really love the way that you said about partnerships, because that is a key initiative for Spark IoT team. We can't survive without partnerships. And this goes across the board, not just water, but any IoT implementations we're seeing. It's about partnerships, it's about working together with people who are areas of expertise and coming together with a collaborative approach. So yeah, thanks for mentioning that. I'd like to invite Jessie back on stage. And As mentioned before, we will go to your questions, and thank you very much. I'm starting to see some coming in. Do use the upvote, and do put all your questions in there. Even if we can't get to them by the end of the session, we will look to answer them. But also, as we did halfway through, we also ran a poll and the results for the poll. So the question was, are you in, I'm just going to check what my wording is, are you planning or implementing an IoT trial in the next few months? Quite, I'm presuming this audience obviously is quite engaged in this, but what we're seeing here is 52% of the audience are. So that's a fairly high percentage of people who are about to look at implementing a trial. So it's good to listen to what Jessie and Hugh have had to say with regards to their experiences. But let's head over to the questions area and see what our audience would like to hear more about. Right, well, I'm going to start with the upvotes first. And so Mitchell has asked, how are your sensors powered in order to maintain lifetime in the field? Do you use solar? What challenges have you encountered with this? I'll let you start with that, Jessie.
Yeah. So when we looked at how we were going to develop our product and the particular problems that we were trying to solve, it actually started with underground challenges. So underground, obviously, solar is not a technology that you can use to harvest energy, and traditionally. In many of these scenarios, devices would be running all the time. They'd be logging data non-stop. With a lot of the modern IoT technology, you'll find that devices sleep for the majority of the time, and so they can conserve energy. This actually means that you can run a deployment or a device underground, above ground, wherever, with a traditional battery. Now we use a lithium thionyl chloride battery. That's a long life, high energy density, low leakage battery. So what that means is that the battery doesn't deplete its energy over time by itself, or it does so at less than 1% per year. So it's a type of battery that is generally used in military and industrial devices. And it means that we don't need things like solar panels or cables or any of the extra bits and pieces. And that allows us to actually drive the price and the complexity down.
Has it also helped by the low power networks as well?
Yeah, so if you do a comparison between 2G and 3G and the LTE M1 and NB-IoT networks, you're looking at almost a 10 times energy reduction.
Brilliant.
But also add in there, Jessie, what's really important here is not being tempted to have a cadence that necessarily reflects what you might get in a hardwired SCADA system at a treatment plant.
Yeah.
Sure.
So I would have started off with Jessie saying, Jessie, I need this every 5 minutes, and he would have said, why? Why do you need that? And actually, I didn't. I needed something quite different.
So the other interesting thing is that over time you can you may want to start off collecting as much data as possible, but over time you can actually get the devices to learn what they need to do and communicate less data, but then be more reactive. So if for example, there's one of those scenarios that Hugh showed on screen earlier, where a customer has removed a reduction valve. If that tank is filling faster than it should be allowed to fill, we want to be notified about that. It may be that there's a truck filling it up, or some other reason, but it's good for the operations team to at least be notified that something's going on, and maybe they should have a look.
Sure. I know that you've answered this a little bit from the 4G, 5G, 4G Cat M1, but Just wondering, how was your experience with 4G versus Cat-M1 in remote farm areas in New Zealand and Australia?
Okay, so it's a lower bandwidth technology, which inherently means that it can communicate further from a base station than 3G or 2G. So in Australia, we were very surprised on some low-lying agricultural land in, I guess, directly north of Adelaide. We actually received connection with the Telstra towers 52 kilometres away. Now, there was only something like a 50-metre elevation difference across that area, and we were really, really surprised. Now, in New Zealand, we have probably seen some similar scenarios where we actually get coverage and it's not on the coverage map. It's been a very interesting discovery process and learning process.
Yeah, and I can speak to that also from the Spark IoT team. We're finding that across the board, that we've got a sniff of a signal, that the Cat-M1 is seeing better results, definitely. Stephen would like to know, for your agriculture customers, do you have any farmers who use Waterwatch? If so, what challenges do you have with tech adoption and selling to them?
Actually, the majority of our customers. So if you look at our customer pool, you might have an organisation like Citycare who have hundreds, maybe even thousands of sensors. But then you've got many organisations, farmers, who have ones, twos, fives. So what we've found for them is that the technology adoption side of things puts them somewhat outside of what would be our normal customer. So a customer that, or our ideal customer, a customer that is open to learning about technology and taking on many of the challenges themselves. So these, I don't want to say that that farmers are behind the eight ball, because they're not. But there are a large number of them who would prefer, for example, to get a text message than to open up the app and to browse through and look at all the features that the technology offers them. What we've actually found is that in many instances, we actually have to activate the device before we send it out to them. They install it, and then we can remote control it for them when it's installed. And that basically means that it takes them 5 minutes to do the installation.
Sure. How about one here for you, Hugh? Static or dynamic IP for the IoT devices?
Oh gosh, I'm not sure I actually can answer that. I'm sorry. As a user, so, yeah, no, I don't think I can answer that. I'm sorry.
I think that's a perfect situation for me to jump in. For an end customer, it shouldn't matter at all. That should be entirely hidden from them. They don't need to care about anything like that. Now, for battery-powered remote IoT devices like Cat-M1 and NB-IoT, those in most cases, if not all cases, it should be dynamic, and the connections should be led by the devices. That takes the pressure off the IoT network, but it also means that when those devices connect, you can send jobs and tasks to them. So it's, all the communication is led by the device, and that device will have a special serial number, some security keys, etc., etc. So you can validate that that's the particular device that's communicating with you.
Fabulous. Okay, I'll let you two decide who's going to answer the next question. I'm sure you both can. Is there an IoT solution for water meters? i.e., we have a bunch of rural customers on metered connections, and going out and reading those customers can be quite a challenge. Are there any deployed in New Zealand?
You can take that one, Hugh.
So absolutely, and it's certainly something, and we've been working on with Tussock, but also look, there are a range of water meters coming out of Europe. They all have different benefits, different quality, different outputs that, and you have to know what your meters are that you've already got, and what output you can get. You know, what you can get a pulse output from them. What is the reliability, the R49 factor, and where your network is as well. And you know, have you got the Cat M1 network available? Because it is quite dependent on where you are in the country. Once you've figured out those things, and you've also decided what level of data you want from them, once every 24 hours, or for some reason you want it once every 5 minutes, and I caution you about that. Then yes, there is certainly technology there already, and I know Spark have some of that available. We've deployed it, so there's definitely technology available that is stable. Like I said earlier, we've been down rabbit holes before. A great place to learn. You get very hurt, but that's part of life. And come back up and say, no, actually, now I know who I want to work with, and give me a stable solution. So I know you can talk to Spark about that. I could talk about products, but I would rather not right now.
Yeah, no, for sure. And in response to you, Jason, we can give you some more information with regards to that. Aubrey would like to know, do you have redundant communication paths for compliance-related data where comms outages cannot be tolerated? And what is your alternative communication path?
So there are a variety of options out there. We don't ourselves have a redundant network or communication path, and there's a reason for that. Basically, we're trying to keep the price of our product low, and instead of having a redundant path, we actually log and store data on board. So it gives the network time to recover, for example, or be repaired, and then we can upload that data as the network appears. So there are a variety of different ways of tackling that challenge. Personally, and within our business, we've tackled that by logging on board, and then recovering when the network recovers. It means that we can keep our price a bit lower.
Fabulous. Do you have, this is for Jessie, do you also have automation solutions that can trigger events from your other sensors? For example, run pumps when fill levels exceed thresholds. So
basically what we've done is we utilize our cloud platform as a bit of a funnel. And this actually can be an answer to someone else's question up there about data historians and that sort of thing. Basically what we do is the data comes in from our sensor, we decode it, we verify that it's from a known product, and that we validate everything, and then basically we funnel it out to different areas. So if you're wanting to control a pump, for example, you could have a pump controller that's generally pump controllers are powered, and they can be connected to the internet, and they can run the whole time. We don't have one ourselves, but we are looking to do something like this in the future. And so basically you can fire that trigger into that controller, and away it goes. The same goes for the data. So the data can come in and get fired out to a data historian, or to the likes of Hugh's team, who will then combine it in their larger IoT platform, or their operations network, and then they'll do other things with it. So I mentioned earlier in the presentation that the manufacturer will generally have some kind of device platform. Those device platforms are really should be seen as a positive thing, because what they do is they best utilize the technology for low power, and they also provide a tool, a very integrated tool for managing the life cycle of that product. Once it gets past that, I feel like you should be free to do whatever you want with the data and control it, manipulate it in the way that that is going to be beneficial to your business.
Fabulous. All right, we've got time for one more question, and I'm actually going to throw it to both of you, even though it is addressed to Jessie. What has been the biggest challenge you've faced in getting to where you are today, and what did you learn in terms of coming up with a solution? You each have a minute.
Go for it, Jessie.
So the biggest problem that we faced getting to this point today, we were ahead of the 8 ball. We had our first MBIoT and CAD-M1 device ready in 2017, and there wasn't a network in New Zealand. There was a network in Australia. We flew to America. We did some testing there. A year later, we went to Australia, did testing there. Basically, we got caught up in the hype, and that's an easy thing to do. You can get caught up in the hype. We've learnt from that. We've slowed ourselves down, and we're about to release some newer products with other technologies like satellite, but we don't want to get caught out. So we're slowing it down and we're taking our time. We're verifying very hard internally before we go to market.
Nice.
I've probably got 3 things. Partners, very trusted partners, working with them collaboratively. It's really important. Getting the right team behind me. Let's face it, I don't do all the graft, but the right team behind me to onboard the technology, so that we know when we get a data point, we can trust that and we know what to do about it. So onboarding that technology, and also keeping an eye to the future. So we've got some stable technology. It does what we need it to do. But what's next? So those are the challenges. We're trying to get stuff work now, and it works wonderfully. We're keeping an eye to the future as well.
Fabulous. Thanks, Hugh. I'd like to thank both of our speakers today, Jessie from Tussock and Hugh from Citycare Water, for being so generous with their time and sharing so many insights with us. I'd also like to thank you as the audience for joining us online and participating with the questions and the poll. Remember to check out the website, or our website. There will be a recording copy of this webinar on the website for you to view and share with colleagues and friends. Or should you be interested in finding out more information about Jessie or Hugh's services, then feel free to email us at iot@spark.co.nz. From me and the Spark IoT team, stay safe. Kia kaha, kia maia, kia mana, wanui.